Hello, Algebra 2. This is the last video for Chapter 3, all about systems of equations. Now in Section 3.4, we didn't have a video. We worked with some matrices to solve systems of equations. We're not so much solving systems of equations today, but we're going a little bit farther into matrices. So a matrix is really just a fancy name for a table of some kind. And we see a table here. It's labeled out really nice for us with children's, student, and adult prices for different times of buying a ticket, for example. So there's a good example there. It's just a good way to organize information. And for reference, each one of these little guys here is called a cell. So we have different cells of a matrix. So let's go through this exercise down here to see what we can do. And again, it's just a matter of looking at the table and seeing what they're asking us. So here we go. During each of the last 3 weeks, a road building crew has used 3 truckloads of gravel. The table at the right shows the amount of gravel in each load. So we have the 3 weeks and then 3 loads in each week. So there's always a side-to-side categorization and then an up and down categorization. So here we go. Determine the average amount of gravel in week 2. Okay, average amount of gravel in week 2. Week 2 is here. My average amount of gravel is going to be if I add all of these amounts up and then divide by 3 of them. So if I do 40 plus 40 plus 32, I get 112. And when I take 112 and I divide it by 3, it doesn't work out exactly evenly for me, but it is 37.3 repeating tons. So that's the average there. What was the total amount of gravel delivered in load 2? So the total from load 2. Load 2 is right there, so I'm going to get 32 plus 40 plus 24. When I add those up, I'm going to get 4, 5, 6, 7, 8, 96 total, so I can stop right there. That is in tons as well. Which load delivered the most gravel per load? Which load, so load 1, 2, or 3, delivered the most gravel per load? So that's going to be sort of the, excuse me, the average of a load. So not the average of a week like we did in part A, but the average in a load. So load 1, I have 40, 40, and 32, which is going to take me up to, so load 1, I'm going to have 112 again. When I divide that by the 3 weeks, I get my 37.3 repeating tons. Load 2, I have 32, 40, and 24. I already added that up in part B, so that's 96. But when I divide it by 3, that gets me 32 tons. And then last, load 3, I'm going to have 32 and that's going to be 0. Carry the 1. Sorry, I'm not working with a calculator today. 3, 4, 5, 6, 7, 8. 80 divided by 3. That gives me 26 and 2/3. That's 0.6 repeating tons. So, which load delivered the most gravel per load? When I take this average here, I see that it is load 1 was the best by far. And during which week was the average load the greatest? So during which week was the average load the greatest? I'm going to get very similar numbers here. I'm going to get, for week 1, 96 again, divided by 3, which gives me my 32 tons again. This is separate, but they are very similar answers. Week 2, I have 112 again. Divided by 3, I get my 37 and 1/3, or 0.3 repeating again. And week 3, I am going to get 80 again. Divided by 3, I get my 26 and 2/3. So ended up working out very closely here. This one, which week was the average, the best, that's going to be week 2. So week 2 was the best, load 1 was the best, generally speaking. So, again, just a way for you to organize some information. Let's talk about a more abstract way for us to use matrices, and that is with some operation with matrices. Now, when we used our graphing calculators to find the answers to systems of equations, and we used reduced row echelon form, that answer, what your calculator was going through, was partially this stuff that we are doing right here. It needed all of these operations to do those things that it was doing. So some things that we can do is addition and subtraction, and it's super easy. You just have to make sure that your cells line up. So for addition and subtraction, my matrices have to be the same size. So I have to have the same size. Now, they don't have to be square like these guys are. Notice how these are both 3 by 3 matrices, and we're subtracting and adding those. They don't have to be like that. They could be a different size, but they both have to be the same size. So I get something like A, B, C, D, E, F, G, H, something that's tall and thin like that, and I could add that to another matrix that is also tall and equally thin. Something like that is fine too. So I just take cell number 1 and I add it with the other cell number 1, and that goes in my cell number 1 position in my final answer. And we just go through like that. So let's try some of these. Let's go for down here, number 1. Number 1's fun. I'm subtracting. Don't forget you're subtracting negatives sometimes, so be aware of that. So here we go. 8 minus negative 4. Well, I know that gets me 12, and that's in the upper left-hand corner. 7 minus 3, that gets me 4. Negative 10 minus 2, I get negative 12. Negative 6 minus negative 12, so that's actually a positive 12 there. With my negative 6 gets me positive 6. Notice how my answers and my operation matrices here, they're all the same size, I can add as well right here. Try this one out for me in the answer box. And what you do is just type like number, enter, number, and it'll give you what you need. So try that out. Add those two matrices. And let's think about it ourselves in the video here. Let's find the answer. If I add these, I get 2. Add the negative 5 and the 3, I get negative 2. 9 and the 2, I get 11. Negative 3 and the 6, I get positive 3. Negative 4 and the 9, I get 5. 5 and the negative 4, I get 1. Again, it's the same size the whole way through. Now, another operation that we're going to talk about is scalar multiplication. So a little box here that says what that is. Scalar multiplication means I take a nice normal number, so a constant number, and I multiply the whole matrix by that constant number. As you see right here, all it does is that constant number gets multiplied to every single cell along the way, every single cell. Think of this kind of like if you had a picture or a clip art image in like Photoshop or a Word doc, whatever, you could make it this big, right? Or whatever this picture is. And then if you scale it big, every single part of this gets bigger. So like if you, there's those little handles on it. If you take the corner handle and stretch it big, the whole thing gets bigger, right? Every single aspect of it gets bigger. Same thing with the matrix here. Every single aspect has to get bigger, every single cell. So let's try number 3. It's super quick here. I need to multiply 3 to everything. I am going to get a matrix that's the same size as my original answer. So I have 3 times negative 4. We have negative 12, 15, 6, and 9. And that is my final answer, and life is good. Now, number 4 we see is a combination of those. Let's take a look. For the first part, this is the question number, I need to multiply this negative 2 in, so I get negative 16, 2, 0, negative 10, negative 12, positive 12. And then I multiply the 4 in as well. And order of operations still holds true here. I need to multiply before I add. So I multiplied the -2, and now I'm going to multiply the 4 before I add. So when I multiply the positive 4 in, I get -4, 0, -4, 20, 40, 60. Now, I would add these if I could, but I can't, unfortunately. We are only allowed to add matrices that are the same size, the exact same size. So the up and down dimension matches. The side to side dimension matches. Just like all the ones we've done so far on this page. This one does not match. Therefore, my final answer is sitting right here. There's nothing further I can do with that because the sizes don't match. There we go. So, that's all we have about matrices. And we will talk a little bit more about those in class. Again, this is helpful to know how our calculator is working that reduced row echelon form when we are solving systems of 3 or more equations. There we go. Yeah, I think that's it. So, we will talk about this more in class. That's the last video for chapter 3. So we are rocking and rolling our way on to chapter probably 4 soon. Hooray. Alrighty, see you in class.